Uno, dos, tres. Hi, everybody. Don't worry, my presentation is not going to be in Spanish. It's going to be in English today with an accent. So, my name is Luis Ruiz. I'm originally from Mexico City. I'm an architect, and I'm a Vectorworks user. First and foremost, I started with Minicad 3, and about 10 years ago, I immigrated to the United States. Did my practice in architecture north of the country, and it's been about four and a half years since I joined the forces for Nemetschek Vectorworks. So I get to create projects, but in this case, I don't have a client. So budget is no limit. This is great. Now, beginning of the year, we started with the idea of let's see what happens in the BIM world. In this case, nowadays we have, of course, we have Vectorworks, we design, we create drawings. Some of us create, we use Vectorworks in a BIM fashion. Now, part of it here is explain that what is the difference between working in a closed environment and working in an open environment. But how do we do that gap? So, for example, this is one of my projects from 2004, something like that, a small office in my studio. In those days, the architect would say, Luis, you gotta go to this place, measure the place, come back again, create the model. And once we have the model, well, you got the floor plans, the sections, the elevations, the spreadsheets, all of that. But when the contractors came by to pick up the drawings, well, we had to plot the drawings, give them only the drawings, paper, PDFs maybe, and that's it. So the model that we used, they never got it. They never got the needs for that. So the idea for this project, this is a proof of concept, is so how do I go to the next level from closed BIM to the big BIM when I need to work with other team? So by January, we decided to put a team together, people who were willing to offer the time and their knowledge from different places, different countries, UK, Brazil, West United States, Netherlands, and Dominican Republic. So everybody from the different specialities. So we had an energy consultant, a contractor, quite a few, structural engineer, a BIM manager, you hear about it, an owner, and we also had an architect, of course. I played the role of the architect. So, like Barry explained, Building Smart Alliance, just a little background, Building Smart Alliance created this initiative, and they decided that, hey, it would be a great idea if all these vendors could actually talk to each other, because all these industries have different applications, but the common language here would be IFC, industry foundation classes. Now, just so you know, IFC is the way to go. You have to use IFC in order to have an open BIM environment, an open BIM project. But what is IFC? Just so you know, IFC is geometry. In this case, we have door. That object has a definition, so it knows the name, it knows what it is. But it also has a relationship. The doors, the objects, understand that they are connected to another object, like a wall, and that wall lives on a story. And that's what the IFC is all about. It's transferring that information to place. Now, yes, many companies, many vendors are developing right now IFC, and as you see, the major companies are in this. So we have Autodesk, of course. We have Nemetschek family, we do have DDS, and so many others. And this is just evolving, this is growing, so watch out. Now, here we go. Now, the test. This is the McLeamy curve. When I saw this curve the first time, when I saw this graphic, I had to understand, wait a minute, this is 3 ways of creating the same project. You can do it by hand, but you know, changes happen in a studio, so we're architects, we need to make some changes. We're never happy, but if you do it by hand, at the end, if you make some changes, well, you're gonna suffer. Budget is gonna suffer. But if you do it in the middle, let's say that you're using CAD, you're just drafting, even if you use Vectorworks on 2D, then changes happen in the middle, you're going to suffer a little bit, but not that much. Now, in a BIM environment, that means you have to put a lot of information up front. That means that the architect and your designers need to collaborate close together and make decisions up front. There's a lot of work. But then after that, everything is just a piece of cake. It just cruises along, no problem. And that's what I'm going to be focusing on the first part. Now, on this graphic, for example, this is what happens in right now, typically in the United States, the evolution of a project. You land the project, you land the commission, you get it. Then what happens? Well, you enter into your pre-design development, you move on into your schematic design, design development, and finally into your construction documents. And if everything goes well, we send these documents out for bidding, and construction starts. Now, if you're working in a BIM environment, you have certain rules. There's a few steps. Now, don't get scared. I know it looks a complicated graphic, but the idea is, for example, in the United States, the AIA, the green bar, it's been very well defined, the steps, levels of development of the project. Level 100, for example, mass model. Levels 200, basically what we're doing right now in 3D model. 300, when you combine all the disciplines together, architectural, MEP, structural, all together, just so you have an idea. 500 at the end, it's the real thing. It's just the construction. Now, other countries like Finland and Norway, they do have their own system, but they all relate to the same thing. In this test, we just decided to divide it into something simple. You have conceptualization, you have design intent, you have constructability, and facility management at the end. So that's what this project is all about. Now, the process. You create, the idea comes, you create it, you land it, you model it, you validate it, you have to test it, if that is fine, and then you share it. You share it to your collaborators. They in turn, they're going to give you back their ideas, which you have to incorporate into your original design, test it again, out to the contractors, and that is the cycle. Now let's get to the project. On the right side, I have, the project is based on an apartment building. On the right side, you see all the elements that made this possible, this building. All these are Vectorworks pieces. In the middle, you have the BIM project. Then out, you have IFC information, and that information will go out to the contractors. Each one of them will be using different applications, and they have different specialties. Each one of them will send you back an IFC file, which will be incorporated into our files. We make decisions out again until the project is finalized, fine-tuned, ready to go. And then, of course, we get into the construction document. If everything goes well, that's how it goes. Now, let's talk about the first part, conceptualization. How do we get to the design part? This takes a little time. This is the cream of the project. Now, I needed to have a project in this case, so I decided to contact Ruben Hernandez, one of the top Vectorworks users in the world, and he's also a professor. Now, he has this building. It's called the Arboleda building. This one is in the Dominican Republic, Santo Domingo. Very unique style. And when I saw this project the first time, it was done in a BIM fashion, closed BIM, but it was in a BIM fashion to every single detail in that project. You can open the file and it was just heavy because modeled every part of the entire project. Full control. But when he shared his file, he couldn't share the file with the contractors. It was just paper. Now, we decided to take this building and see what happens in an open BIM environment. And by the way, this is, that is the building. That's not a render. That's the real thing. And just so you know, that picture was taken from his classroom. I forgot to tell you, he's a professor, thesis professor, so he can see the students, look out the window and say, hey, that building is mine, actually. Pretty cool. Now, in this quick presentation, you'll get to hear what we use, all the packages that we use, the design packages. Of course, Vectorworks Architect was our BIM package. You'll hear me mention Cinema 4D for presentations, CAD Faster for communications, Nomad for my cloud services, SimTrade, AirWorks. Now, we'll be talking about Solibri Checker, Solibri Model Checker. In this case, there are two versions, the viewer and the checker, just for testing validating the BIM projects. And my collaborators use IES for energy analysis, Nemetschek Scia for structural analysis, DDS-CAD, Synchro, and Ecodomos for facility management. So I'll give you a taste of this. The project initiated with a site. I decided that it was going to be a little expensive just to fly back and forth to Santo Domingo and replicate the project. So what I decided is, I'm going to put this project right in my backyard. So I put it back in Columbia, Maryland. I decided that I had a site, I had a place, waterfront, and also I had access to geo-reference information. I have the access to the county information, get that geo-reference information, put it back into Vectorworks, and from there created the first model, the site model. Once we have the site model, well, we created a quick mass model just to put it in front, just on top of the building. I had to make decisions, and I wasn't sure if the building needed to be higher above ground, underground, or somewhere in the middle, because I have parking lots. So by combining my mass model and my site model, you get what? First numbers, cut and fill calculations, how much dirt I need to dig, or maybe not. So that's one of the first pieces of information by using 3D model. That's an advantage. Now, like any good architect, you have to start with a sketch. So we sketched this one. This is the floor plan, just so you understand. This is the typical floor plan of this building. That's an apartment building. Three bedrooms, balconies, views everywhere, and just great. And by the way, there's two apartments left. They started in 2008, and last year they closed it. So if you're interested, you can still get it. Here we go. Now, once we have the polygon, we start using our push-pull tool. Get the first mass. That's the typical apartment building. The typical apartment. You duplicate it. Well, that's what we did. We just started duplicating the process, create the base for the parking lot, the top for the roof, and now we have our first mass model. Now, keep in mind, I have not shared any information with my contractors other than my sketch and verbally just the idea. So by having the mass model, we exported that to Google Earth, and we send out the file to my friends, my collaborators, and say, hey, this is what I'm going for. This is where it's going to be located, and this is the shape of the building. Pretty nice. Have you ever used Google Earth in Vectorworks, by any chance? Keep that in mind. So, the sketch. I knew that my 2012 we introduced stories, right? Now the use of stories, I'm sure everybody's, how do I use stories into this project? So part of this Arboleda project was to test the use of what is the proper way of using stories. So we understand that stories is all about control on heights, and this sketch started everything. I know that I needed to know my top slab. I needed to know my drop ceiling is part of the project, because my pipes will go in my ventilation will go right in between the slab and the ventilation. So that I only have 3 levels of control, just so you know that. All right. Now my stories, just so you understand this, stories, for example, second floor contains just simple 3 layers: ceiling, floor objects, and the slab, and that is it. Inside one of these objects, you have classes. The classes you have, it's just like walls, furniture, beam, columns, rating, etc. The key here is if you're doing a BIM project, you have to use classes. Very, very important. You have to have control over your project. Changes will happen. Now here's a view of the stories. As you see, I had about 12 levels. 2 for parking lot, then the typical floor plans, and then at the end we have the roof. And let me mention something. Something that we discovered with this project is that stories is a must you have to use the stories in order to send your files out to other people, because they don't quite understand, some of these applications don't really understand layers or classes, but they do know about stories. So keep that in mind for your next project. Now here we go. Now about the organization. We talk about stories. Yes, you have to solidify your project in layers. Definitely you have to use classes. And if you are well prepared, you can set your file in sheets. And each one of the sheets will have viewports. If you're not aware with the way Vectorworks works, well, this is our organization for files. And it's actually quite simple if you really get into it. Now, let's move on to the first piece. We're going to start creating the project. So we started with spaces. On my left side, far on the left, I have spaces, the space tool. And the space tool was used for creating another type of mass modeling. On the middle one, you have the same spaces, but it's subdivided into vertical unit, apartment building, the typical apartment units, the roof, a parking lot, and then on the last one you have spaces to each one of the rooms. Now, they're all in classes, so I was able to turn it on and off as needed, depending on the information that I needed. So there's another about spaces. Spaces have a tool that not many people use, and I encourage you to use it. It's called the space planning. Space planning in Vectorworks allows you to test your relation between spaces. Do they need to be close together? How far apart they need to be? You get some kind of diagrams. You get feedback when you play with that. It's not going to make a project for you, but it will give you some type of result. Now, I show you spaces because out of spaces we created a first try for a floor plan for the apartment. So I have walls, exterior walls, and I have interior walls. And by the way, you have to remember that these objects that I'm using, they're not custom made. It's out of the box, just the what I call the BIM objects. Walls is mainly one of them because it contains IFC information ready to go. That is our first try. That's what we saw the first time. We saw with a little bit of work. Sound going on? Okay. So now we added to the walls, we added the windows, we added the doors, the railings, columns, and a few pieces of furniture. Slabs are there, stairs are incorporated, everything is ready. This file is ready to be transferred. Now, just so you know, I think I told you that I had to subdivide the project. Well, one file will be for parking, just the way you're doing it. One file for the parking lot. Next files for the units, for the apartments. Another file will take care of the roof, and a fourth file will take care of the skin of the building. Very unique. That skin of the building is not actually structural. It's in reality it's done with styrofoam. It's just for look. It's just for presentation. Actually, really light. We decided to model that piece in Rhino and then bring it back into Vectorworks because at that time we were also testing version 2013, and that's something that we could do. And there you go. You put all the pieces together. You have your first BIM model. Those are some of the views. One side, different isometrics. You pay attention that I have two sets of stairs. One for that's an emergency stair, and then one that is inside of the building. At this level, no textures were applied to this project. I was not concerned about the project with textures, not for presentations yet. But you can see how color-coded each one of the pieces. So you can clearly see the beams, you see the walls, the color for the skin, everything is just separated. Here's just another one of the views. Because of this project, we're able to also start creating images, material for our 2013 release. So a lot of information came out of this project. Now, once you have a BIM model, the first benefit is, well, I need to test it. I need to test if this project is actually safe. And we use safety simulation for, in this case, we use SimTrade. It's a plugin for Vectorworks. We decided, well, what if we had only a floor plan with one single stairs and there's fire, and I have 30 people inside and everybody's going out, probably about no more than 3 minutes, right? But if I had 2 stairs, then fire in the middle, everybody run, building is safe. It's just a great way to test a project. This is Sinter. Now, we have the BIM model, everything is ready, and remember that before we created a site model. So we added some of the extra buildings around it, and now you have another view. Site model with texture, so because we can add a texture to the site model. We have the BIM model in the middle, and what else can we do with this? Well, we can test the Helidon tool and play with the shadows, see the orientations, make decisions. Maybe my design needed to be turned a little angle to the right, maybe to the left. I just needed to know about the shadows on top of my building, or maybe the building casting shadows on top of my site. And let me show you another piece. Because in 2013 we had access to an improved Helidon. Then we have this, a way of presenting the project and testing the project based on the movement of the sun, and also the background moves with it. Really interesting piece, now available in 2013. Soon you'll get it. Another piece that we had the opportunity to use is the clip cube. Now, I had to know that each one of these pieces, stories, was aligned one on top of the other. And instead of being cutting sections and taking the time to just wait for the viewport to be rendered, I can use the clip cube and then make decisions, just push one of the faces inside the building on one side, maybe on top, and then quickly just get a reference of how my project is going. And you can also rotate it and save that view. That's, I show you this because it's one of those features that we have now in 2013, and like I said, I was testing this. Now, presentations. Decided I was not going to use Illustrator or Photoshop in this case. I needed to know how far I can take the model inside Vectorworks. So by using another plugin called Camera Match, I was able to, well, first go to the site, take a picture, take the model, align it, find the right perspective, and done. This is presentation time. You know, it's as an architect, at some point you have to sell the project, and I needed to know how far I can take it. Now, I know that among our crowd we have interior designers, and let me tell you that RenderWorks is a lot, much better nowadays. And this is some of the views that we were capable of creating. Now we add the textures. So these are some of the images on the outside of the project, and why not? We actually went further and took it to the next level. I just wanted to see how far I can take the concept of the interior design of this project. That is the quality that we have nowadays. So that was my typical apartment, the interior, and this is the roof, what I was telling you about. This is the idea that we have for, this is the place for the parties. But most important, the quality is what I was most surprised about. But if that was not enough, let's say that I needed to have animation. I needed to provide the idea to others about how is this building. I knew how the building was built because I saw the construction process. But if I take it to Cinema 4D, then my BIM model can be transferred straight to Cinema 4D, and then simulate how the construction process will go. And this is very similar to what happened in reality. So like I said, I got my model, I have my BIM model, I had static images, I have all the floor plans ready, and I had an animation. That's how I started collaboration, the idea for my partners. Also, augmented reality, AI-Works was available at that time. So, and this is how I started the communication with my structural engineer. I said, hey, and this is just Unreal. Of course, it's over the web. Just flick the model in front of you and start a conversation going. The layers, the layer organization transfers to AI-Works, so it's easy to manipulate. Now, I think I told you that I had many collaborators. So at some point, in order to get the drawings out, I had to work on my machine, but I had to get the drawings. So we make use of the cloud services. We get the file, send it out to the cloud, down can be the PDF with all the drawings set for me, and I'll take it on. It was just something to test, not just on the, and I can view it on my iPad. I don't have an iPad, but I need to get one. But I need, I had an iPhone, so that's my hand, by the way. Like I said, the collaborators, they were all over the place in order to share the communication. So we use, why not? We use CAD Faster because we had CAD Faster at that time. Everybody had access to the right on the fly. We were able to rotate the model, make communications. Each one of them were connected, maybe in the desktop computer, a laptop computer, or an iPad, and just moving the mouse around and flying over. I was able to pinpoint to some of these pieces and say, hey, what do you think about this place? Someone would actually say, hey, let me give you some feedback. So they do some markups, and everybody can just see it. So we tested that, and actually it works. So that was really cool at that time. Now, that was CAD Faster, something that we tested, and wow, you see how many pieces go inside making a design? So it takes some time. It takes some time. Those are quite a few tools, all not difficult to use. So the first part is done. My section is ready. My project is ready. So now it's time to send it out. But in order to send it out, well, first you have to remember, I use only objects from Vectorworks that have IFC information attached, ready to go. Slabs, spaces, stairs, beam, columns, only those objects, except for the skin of the building. I have to attach IFC information manually. So once everything is ready, we export this file, this project to an IFC, and please pay attention to the middle window. You see a little box that says first phase boundaries, and that is the key for sending this file for testing into energy analysis software. First phase boundaries, that was a key. We didn't actually know about this feature until we decided that it was time to see if we can actually do this with another software. And stories were actually added, except for one, for the skin of the building. One of the stories need to be added manually. So there you go. We have a first IFC model. The IFC, just so you understand, is made out of stories. Each one of the stories contains walls, windows, railings, objects. But each one of the objects has an identification. It knows their location, and it has information like quantity, area, height, length, thickness, volume, and relationships, because it knows where it's connected to. And I need to know all that information, because now I'm going to use Solibre. Now, I had access to Solibre model checker, and this one will help me to validate, test my model. Before I send it out, just like, hey, here's my IFC contractor, there you go. You have to test it, you have to validate it, bring down the mistakes. And I had mistakes. Columns were repeated. Visually inside Vectorworks, I thought everything was just fine, but once you bring it into this kind of software, you realize that objects were repeated on top of the other, slabs were repeated, some slabs were actually going between beams, and some of the walls were actually hitting some of the beams, and some objects were in front of others. The Solibre model checker was smart enough to say, hey, maybe you should move your skin a little back because it's just too close. And some of the spaces have no identification, and we learned that some of the applications need spaces. So I had to be sure that the use of spaces is actually correct. And what I wanted to share here is like, it's really something. It's just a new feeling. It's really nice to have a BIM package and a BIM tester side by side. So you may have the opportunity to do this, but it's just a new way of attacking a project. Now, we have our IFC rating done by Vectorworks. We use Solibre model checker. I use Solibre model checker for testing the model, and he's ready to be shared with others. So let's talk about IES. IES, beginning of the year, we decided to make contact with a company that do energy analysis. IES was the, at that time they replied and said, hey, you know what? We're actually using IFC. We're testing IFC and we'll be happy to work with you. Great, so here's the IFC, there you go. And they sent me back and said, we just can't use this because it doesn't have space boundaries. So that's how we learn it. What else we needed? Well, they say we need spaces, you need to have space boundaries, and you need to have shading objects. Objects that actually cast shadows over the spaces. So, okay. So I had to pay attention inside Vectorworks. So I do have spaces. My space boundaries are happening. The space boundary is actually, have you heard about space boundaries? It's an invisible object that happens when a space touches a wall or a door or a window, and it creates that object. That object is what these energy and packages use in order to work, but you have to have it. Once I have the model with all the space boundaries ready and the skin of the building in another format, then we send it out to the to the engineer, and information just started coming back. They were able to do. I mean, I'm not an expert on the IES, but I know that they do wind analysis. They can do solar analysis based on the location of the project. They know the speed of the wind, the pressure inside of the building. They know the cooling and heating based on the project location. And very interesting, they do understand stories. That software understands about stories. They know, hey, let me see what happens at floor number 5, for example. And here's some of the views. They also create some type of renders. So you do have that thermal render technique. And they also send me this image. This is a floor plan image. It's a luminosity calculation. If you see on the bottom side where the stairs and the elevators happen, it was so dark when I saw this image, and I realized, oh, I made a mistake because this is so dark because it needs a window. So when you use a software like this, it helps you make decisions, design decisions, so you can go back to Vectorworks and say, okay, so I'm now going to add a window over here and then test it out again, and everything works. So it's just a design process. At the end, they send a report and say, here is what happened to your project, what do you think about these numbers, and then we test it again. Now, so that was my first collaborator, and the IFC worked, and we learned from it. But the second one, my structural engineer needed something different. We used Scia for this. I sent out the IFC, the entire IFC of the project, everything goes, and he sent it back to me. I said, Luis, I don't think I need all this. Don't give me spaces, don't give me windows, don't give me doors, just give me the skeleton of the building. Just give me the columns, give me the walls, give me the slabs, footings, the foundation if you have it. That's all we need, just your proposal. We'll take care of the rest. So perfect. So inside Vectorworks, we save the view. Once you save the view, you export IFC, and only that goes out. So that's what they take. I'm not an expert on the structural analysis, but this is what happened. I understand that they receive the IFC, and they right away identify, the software is capable to identify the IFC objects, attempt a translation, turns it into structural objects inside Scia, and then finally they get an analytical model, and they start creating these kind of diagrams and reports, and that's how it works. It was really nice to see that, hey, what if, and I asked them, so first of all, what if this project was done in a place where when earthquakes happen? So how is the behavior of this project? Is it going to sustain the stay there? So I asked him, please test this file for for wind forces and earthquakes, and this is one of the first results. So everything you're seeing right now is basically a report of what happened. This is what happened by February, end of February. Now, because of that movement of the building, he said, listen, Luis, your building it requires a little more, it's too flexible. So the core of the building, your concrete walls require coupling because it's just swaying too much. So, but here's the solution. If you add these little pieces in between, then there you go. It's rigid, and that's something that you can use. So I listened to that. We added that piece inside Vectorworks, and they also send me these graphics when, hey, here's the graphics so you understand what happens. Here's the loads, the beams, the structural elements, the slabs, the way they behave, the flexibility, and this is how they started creating the first, they started creating an IFC model out of this. And also, my foundation, there was no foundation provided, but they send you back that information. And finally, I get the IFC back. They also created some sheets, also done in Vectorworks for 2D representation. And now I have my second IFC ready for my structural analysis. And here we go. We're going for our third collaborator. For mechanical, electrical, plumbing collaboration, we have DDS-CAD. We send out the file again, and they say, Luis, you know what? Just you have to have spaces in this project. All right, save the model, save a view, out for DDS, contain spaces, and there you go. These are some of the screenshots that they send me back when they open the file inside DDS, and I never provided any ideas. All I told them, hey, is that, hey, create a project, a ventilation for this project. This is a typical floor plan. So they started, testing that, creating some, adding their own project. They finalized that. They created a plumbing system. They sent it back to me an IFC. I just didn't have DDS, so I was not able to read it. But the IFC, I was able to bring it into Solibri, where I also had my architectural model, and now I can see plumbing and architectural working together. And I decided, hey, so far so good. I think everything is working. Let me see about the pipes. So you isolate the pieces and you see the piping, and it looks very impressive, but I wasn't sure that was actually working. Clash detection. Wait a minute. So the architectural piece and the pipes together, oops, problems. Some of the pipes are actually going through some of my walls. I wasn't sure that was me or that was him. And definitely it was him, because some of the pipes were inside my slabs, and I knew the slabs were correct. And definitely, and those some of those pipes were going through some of the steel beams. So that was a no-no. But my friend in Brazil said, hey, this is how we actually do buildings in Brazil, Sao Paulo. So I said, no, this is not good for international purposes. And see, this is the kind of problems that you identify. So visually, it's hard to find it, but if you use a software like this for model checking, it really gives you the feedback that you need, and you can identify, hey, here we have to. It gives you a report, so you can go back and fix it. Also, this is one of the views that inside Solibri. Well, that was not the idea. You're not supposed to have pipes over the dining room. So I told him, hey, I think you need to have ventilation, wall mounted. And he went back to the board, back to the computer, gave me a smaller profile, something that is more rectangular, and kept all the piping inside the low ceiling area. And this is what they come up with. And finally, so now I have what? The architectural model, I have the plumbing model, I have the structural model, I have the electrical model, I have the piping. And that's what I saw when I put them all together inside Solibri, and I was able to peel some of the top stories and just to see what happens inside. And for me, it was just a wow moment, because I've never seen a building like that on the computer. Really interesting results. We also identified that still we had a few clash problems, so we had to minimize the problems to lower and lower and lower, just to minimize the problems. This is not a real building that we're going to create, but it's just a project that we learn from it, and you're getting this knowledge. Now, we were done with the test. We had all the disciplines ready, and we put them all together. And now you can start getting all these construction documents. We realize that a CAD manager, it may need to be elevated to another level, someone who knows different disciplines, someone who knows how to detect the combination between other products and learn about the IFCs coming from all over the places. So this person can identify all the problems, the clashes, and then fix it. So now we had a better idea of what a BIM manager should be doing. And about construction documents, you understand that inside Vectorworks, you are fully capable, if you are really using 3D and creating a BIM model inside the program. You get the model, of course, and out of that you get your elevations, your sections, your floor plans. But Vectorworks contains a spreadsheet, and if you model that, if you drew it, then the spreadsheet knows what is happening inside the 3D model. So I was able to count the doors, count the windows, maybe put a price to that. Here's another sheet. Create, obtain areas, volumes. Because at this point, I need to create material takeoffs. So it's something that you can do inside the software, but in the case of other contractors, if they don't have the software, they can actually use the IFC model and then run the same process. Here's a sample inside Solibri Model Checker where you can color code each one of the objects, and Solibri will give you a report of all the pieces, not just from the entire building. It can also be just from a single typical apartment unit. And as deep as, hey, maybe I just need the square footage of one space without the doors, because I need to know the amount of paint that I require. Then we decided to test this with Synchro. It's a popular software down in Brazil, as I hear. Building simulation in 4D, which is interesting. Have you ever heard about Synchro? You know? Well, it combines a project, your 3D model, with time. It's a simulation of the construction of the project in time. Let me show you how that works. They are capable of reading the IFC, bring that into the software, import it, and then identify the pieces and add time to each one of those tasks during the project. For example, how is this project going to be 3 or 4 months from now? I think it's going to look like that. So in this little capture, let me show you how that works. You can identify the pieces. In this case, we're selecting all the footings. That makes all the foundation, including the slab. Then on the right side, you can assign, well, I understand that the foundation is going to take this amount of time, plus the first floor. So once everything is identified, you can just roll the scroll bar and you realize, hey, this is what's going to happen in the 2nd month, on the 3rd month, on the 4th month. It's just a simulation of the construction of the project. Right now, this is an ongoing project. Well, we haven't finished the year, and my engineer has for using Ecodomos, has the rest of the information for facility management. We'll bring you information after that test is completed. And this knowledge, and just so you know, this new knowledge that we acquired with Vectorworks friend and these collaborators, well, there was a competition early this year, middle time, right? About sometime in the middle of the year, we had this competition, Building London Live, 2012. Many teams got together and they had to create a BIM project using different disciplines in 48 hours. So I hired everybody and said, let's get on it. And Vectorworks won the Best Design Award, the award for Best Design in this case. So they did it, 48 hours, put the knowledge, the Open BIM knowledge in practice, and they did it. Here is, the competition was done in London, of course, and they decided to they decided to, here's a situation, not to use any of the objects that I told them about, walls and ceilings and slabs, none of that, custom made, because Vectorworks is actually capable of free-form modeling. But when you use free-form modeling, you have to assign IFC information manually, but that worked. And we were able to share the model with others, so others can actually work with that. Free-form modeling was used in this project. All the features for from the power pack station was done. Additions, subtractions. There you have it. This is a, was that a museum? Yes, that was a museum, right? And divided in 2 sections. And this happened at the end of 20 hours. They're not supposed to be sleeping. So at the end of 10 hours, I asked him, hey, what do you have? And this is what they showed me. So they won. But this is just flash news. The same team is right now working in another competition, Building Qatar Live 2012. 48 hours, they're supposed to finish tomorrow, I guess. We'll know if we won. So I don't know, stay tuned. The same team was incorporated, plus some people, some company from India for building, for energy analysis. So we'll see how we did. So what I just brought to you is Vectorworks is a BIM package, not just in a closed environment, in an open environment. This is possible. So I invite you to give it a try. Not in a large scale of project. You can start small, but the tools are there, the knowledge is there, and everything that you saw over here will be put together in a series of mini videos for you to learn from this. This will be on Service Select only for our customers. And at this point, I thank you for your time, and I'm open for questions if you have any. Too much information? Yes, but it was a lot of work.
The synchro package, is it also combined with like the MS project file, and are you really planning and simulation in the same package?
I couldn't hear you, I'm sorry.
The simulation and planning, is it in the synchro file, and also do MS project plannings or other planning packets including? Because it's interesting for if you're on the construction site, viewing the plan to the constructor and also to the owners.
What I know about that package is that it takes the object and it brings back out a report and movies at this point. I need to know more about that section, about that part. So I think I need to get back to you on the synchro section.
Yeah.
All right. Well, thank you again for your time. Yep.